Hello, welcome to Chapter 4 in Business Analytics as we discuss data visualization. In Chapter 4, we will cover how to visualize a single variable, how to visualize the relationship between two variables, and then visualize the relationship between two or more variables. The first method we're going to look at in data visualization is how to visualize a single variable. A frequency distribution or overall element to say a volume of something or frequency, right? When we're measuring time or money or how often a customer conducts a particular purchase habit, etc., that is frequency. A straightforward bar graph can give us a visualization of that. So for example, the repeat variable. How often does a customer repeat, yes or no? And as we can see, that the answer is yes, frequency 140, and no, 60. Right? Relative frequency 0.7 and 0.3. What this means is 70% yes, 30% no is how you look at relative frequency. And they compare and contrast visually side by side. Yes outweighs at 140 versus no of 60. The same can go for the gender variable, male and female in a particular respondent set, say, or customer data set to find out between male and female. While males are 150 frequency, females 50, at a 0.75 frequency, which is 75% of the distribution, and 25% of the distribution is 0.25 female. It's really just taking a numerical value data set of a single variable, here saying yes, no, or male versus female, a very straightforward view of a single variable. A bar graph is very straightforward. Now, taking it a step further on how to assess a single variable in data visualization. With a numerical value, each observation represents a meaningful amount or count. Although different from a categorical variable, which you remember from earlier chapters, is overall a categorical value that can change or is scalable, we still use a frequency distribution to summarize a numerical variable. For a numerical variable, a frequency distribution groups the observations into intervals and records the number of observations that fall into each interval. For example, again, you could have sets of intervals such as 1 through 100 and group them into groups of 20. The relative frequency for each interval equals the proportion of observations in each interval. So what this means is there's 5 groups of 20. 20 times 5 is 100, but you could take those down to intervals of 20. The data are more manageable using a frequency distribution, but some details are lost. So again, it depends on what you're trying to do, but breaking them down into groups can also help your data set. Taking the notion of intervals a step further. Instead of categories, construct a series of intervals, or at times they're called classes. Well, we must make certain decisions about the number of intervals as well as the width of each interval. The intervals are mutually exclusive. The total number of intervals usually range from 5 to 20. Like I said, out of 100, you could have groups of 20 each at 1 through 19, 20 through 39, 40 through 59, etc. What that does for you is allow you to provide 5 different groups if that's right for your overall range. But 5 to 20 is really where you stay. Smaller data sets tend to have fewer intervals than larger data sets. If we have too many intervals, then the advantage of the frequency distribution is lost. If the frequency distribution has too few classes, then considerable accuracy and details are lost. The intervals are exhaustive and the intervals are easy to recognize and interpret, which is what we want. We don't want an exhaustive list of intervals. We want groups that make sense so we can break them down further if we need to into deeper analytics. The next method of a visualization technique is called a histogram. A histogram is the counterpart to the bar chart to visualize a frequency distribution. A histogram is a series of rectangles where the width and height of each rectangle represent the interval width and frequency, or relative frequency, of the respective interval. What this means is it takes that bar chart view, but then breaks it out into each of those different groups and different segments or overall numerical ranges you are looking to subset or put into a class. Mark off the interval limits along the horizontal axes. The height of each bar represents either the frequency or the relative frequency of each interval. No gaps appear between the interval limits. Let's take a look at an example to make more inference on this. This is the data visualization of a histogram. Again, a histogram provides information about the shape of the distribution. Symmetric is a mirror image of itself on both sides of its center. Now, skewed, though, an example of that would be positive, elongated right tail, or negative, elongated left tail. Left means left side of the very symmetric center of the histogram. So, for example, group A, or the example A, symmetric distribution, is a overall symmetric distribution that has a very straightforward left tail, which is everything left to that, and everything right to that is the same size as the left side, meaning that it's very focused and is a good histogram to use to understand there's no skewness in the data. Now, in this next example, B is a positively skewed distribution, which means everything to the right is more on the other side of the spectrum on the horizontal axes, higher values of intervals than the center, where there are three groups to the left, to the right of the center higher bar graph. Now, option C is negatively skewed distribution, everything to the left side of that center high bar graph. What this means is all the intervals on the left side of the left wing are elongated and also are negatively skewed distribution, meaning that there's more on the negative side of the center. What this means is that the intervals on the left side of the negatively skewed distribution has a potential impact to the overall data set and potential results that may not provide adequate details for analytics. It just depends on your analysis approach, but this is how you read an overall histogram from a data visualization perspective. Let's take this frequency distribution and histogram to a further example. Here we have intervals in the 1,000s of dollars, but as you can see, they're broken down into 5 different intervals. Anything between 0 and less than or equal to 50, anything between 50 and less than or equal to 100, anything between 100 and less than or equal to 150, and so on, all the way to the 5th interval. Now, the frequency is the number of different observations or data points in between each one. So there are 40 individual data points or observations between 0 and 50, between 50 and 100 or 132, etc. But we can already see by the table view that 132 is the highest distribution. Okay, the relative frequency is 0.66. But if we want to take a look at it, though, what this means is on this particular frequency, we have at the center of it, the highest frequency, that everything to the right is, we have more to the right than we do to the left. We have more of a positive distribution of dollars spent on the right side of the overall higher interval. So therefore, we can look at this and say, yes, our highest interval of dollars spent or sales is 50 to 100, but we also have a good percentage to the right as well. Another important factor to consider when it comes to providing a line chart in a data visualization is that you could actually have the vertical axes and the ranges, if you will, or intervals too far apart to where you're not getting the true evaluation of the line graph. For example, here on these two charts on the left side, the vertical axis should not be given in a very high value as an upper limit. So you want to make sure your upper limit and overall scope of going from bottom to top has the right level of intervals so you can have a good view of the line and variance in the data. The data may appear compressed so that an increase or decrease of the data is not as apparent as it perhaps should be. So on the left side example, you can see the original was 75 to 125, 175, 225, etc. It went up about $50, if you will, in each of the different intervals of measurement in the vertical axes. Well, now we spread it apart a little bit further and go by $10 increments, 80, 90, 100. And what that does, it stretches it out. It takes it from a stretch out view to a more compressed view that allows us to get a very more focused and finer look at the line graph so we can see the better trend of our analysis to get more precise in our data analytics. This is a very important visualization technique. You want to get more focus and make sure that there are intervals so you can view the data and line graph to find out those true insights and overall ability to understand what's going on in the business. This is another example where the vertical axis should not be stretched so that an increase or decrease of the data appears more pronounced than warranted. For example, here on the left side, we're going from $59 to $60.40, but on a stock price at 20-cent intervals. But as you can see, by doing that, though, it makes it look a little bit more structured than it should be. The corrected vertical axis is actually spreading it out further. This is an example. It's okay to stretch out the vertical intervals a little bit more, doing this in $2 increments, because what we really want to look at is the range from a dollar perspective and not down to cent. This again depends on the level of variable you want to consider and analyze, and whether or not to go up or down in the vertical axis intervals is really at the discretion of the analyst, depending on the visual and the depth of the analytics you're trying to display. Now, here's an example of methods to visualize the relationship between two variables. So for this, an online retailer recently sent emails to customers that included a promotional discount. The retailer is wondering in this analysis whether there's any relationship between the customer's location and whether the customer made a purchase with a discount. So these analysts want to know if location has any correlation to purchase. We can do this with a stacked bar chart. We'll look at that in the next slide. As you can see here, though, there were over 600 emails sent, with individual records saying the first record was one email to the west location, and yes, they purchased, all the way down to the 600 record was sent to the south, and no, they did not make a purchase. Let's take a look at this visually in the next slide. Here's where you take what we just looked at in the data set and use an example of a bar chart or a stacked bar chart. What we can look at here is taking each of the different regions from the Midwest, Northeast, South, and West, and see that we have between each one a stacked yes in the red and then the blue no. So the Midwest had 107 say no and 77 say yes. Well, this would be important so it visualizes very straightforward to the viewer that they can see the popularity or not popularity of a certain region. We can see that all of the regions had a pretty high yes count, whereas Midwest had a lot of no's. This could lead the strategist and the overall analyst to say there's something we need to do with the marketing of the Midwest. Perhaps try a different discount, a different way to market to them, with a different campaign, whatever that means. But this is a good way to provide visually a view of the relationship between who opened an email, yes or no, and the region they're from. The next method of visualizing a relationship between two variables is called a scatter plot. A scatter plot is used to determine whether or not two numerical variables are related in some systematic way. Each point represents a paired observation for the two variables, referred to as one variable as x-axis and the other as y or the y-axis. Once plotted, the graph may reveal one of the below: a linear relationship, a non-linear relationship, or no relationship. The linear relationship is definitely going to be something that is what we call linear in between all the data elements in a fashion that there are correlations, starting from the top of somewhere in the y-axis down to the x. A non-linear relationship means that it's not having a high y-axis output of data and moving up as the further you go down to the x-axis, so it's non-linear. Now, if you have nothing but a hybrid middle between the y and x axes, such as the far right example, that is no relationship, meaning there's no correlation or lineation between the two variables. Here's an example of a scatter plot where we're showing the annual income on the x-axis of all the individuals that are being analyzed. On the left axis, the purchase amount in dollars in the thousands. So 200,000, 400,000, and so on. And at the bottom, annual income of the actual individual respondents, 50,000, 100,000, etc. Well, we can see based on the scatter plot, there's a big mix between house values sold from about 200,000 all the way to 600,000 from anybody in the, let's call it $50,000 to $100,000 range. And then the outliers, of course, show the higher income levels above 100,000, and then the higher purchase amounts up to 800,000 or more. So this is where you scatter plot it though and build out segmentation within it and find there's a linear correlation between those with lower incomes and lower house values and those with higher incomes or higher home values with higher home values, which means this is linear in correlation, which in theory makes sense. The more income, the more affordability of to buying a higher end home. But this is an opportunity to take it from a visual perspective and plot it out to find out where the overall groups or intervals are on a plot chart perspective. The next type of visualization technique to look at two or more variables is called a heat map. A heat map uses color or color intensity to display relationships between variables. A heat map is especially useful for identifying combinations of the categorical variables that have economic significance. There are a number of ways to display a heat map. They use color to communicate relationships between the variables that would be harder to understand by simply inspecting the raw data. Let's take a look as an example on the next two slides. In this example, we have a data set of a national bookstore chain who's trying to understand customer preferences at various store locations. So again, they want to look at individual customer records and how they have a correlation for their preferences of a certain type of book based on location. The marketing department has acquired a list of 500 individual customers of the most recent transactions from 4 of its store locations. So there's 3 variables here: the actual customer record, the bookstore location, and the type of book. Now let's look at this from a heat map perspective. Now, after taking that data set of 500 respondents or individual customer records, in Excel, it's a simple insert pivot table, home, and then you would color coordinate the heat map. What this does is show that the red would be the actual lower percents, the ones that have the lowest attribution of a customer with a certain book type and a certain location, and green being the highest location for a particular book type. So as you can see, the higher green values for biography is in store 3. Customers who prefer biography books have a higher percentage of buying more often in store 3, and the lowest in store 2. You can take that all the way down the different categories from children's books, romance, sci-fi, self-help, and travel guide. But what we can do here is say, for example, from a category perspective of book, self-help has the lowest attribution of any sales in any store. So self-help actually is not the most popular genre of book, period, regardless of store. That could be a strategy to do something different about those books, or maybe not consider really marketing those books very much. Now, the highest correlation of the most kind of in a heat map perspective of green is under sci-fi. So while sci-fi is not the most popular in every store, it still has in a heat map perspective higher percents of sales across 3 of the 4 stores. Therefore, sci-fi is more of a general category that can be marketed towards all 3 stores or most stores if that's the targeted strategy. So again, a heat map can give you a viewpoint on category, location. In this example, a heat map gives you a visual to take different perspectives and take a step further to identify strategies to take the opportunity to the market or increase the various focal points of your data set. Thank you for your time, and this concludes our overview of Chapter 4. Remember, data visualization tells the story of the data. Once our data is ready and able to be used, we must plug in various elements of visualization, from histograms to plot charts all the way to heat maps. These visualization techniques allow us as analysts to tell the story to others where the opportunities are in the business based off the data and insights. Thank you so much for your time.